Okay, so good morning to all my dear students, faculty members, and the colleagues who are present over here. Today we have one webinar which called as a deep discussion in structural analysis. For this, we have a guest speaker, Assistant Professor Chandrika Vinayak Rao. She is from Dhirajlal Gandhi College of Technology, Salem, Tamil Nadu. She has various knowledge in structural analysis, and today she will share her knowledge in regarding structural analysis. Okay, ma'am, I will hand over to you.
Yeah, thank you, sir. First of all, I will like to thank PU University to invite me to give you a brief webinar on structural analysis. Yeah, I am Chandrika Vinayak Rao. Here I am going to have a webinar session in a deep discussion in structural analysis. Basically, my area is based on purely structure because I did my ME structural and now working as an assistant professor only in structural analysis. A deep discussion in structural analysis, which literally means only the analysis of a structure other than your book contents, because all pre-final years, final years, they are well thorough in their structural part, structure either structural 1 or 2. But other than the book, we want to have a knowledge how a structure is going to be designed and has been analyzed. Is I am audible to everyone?
Yes, ma'am, you're audible, but slide is blinking.
No, sir. No, is this correct?
Now it is good. You can move forward for this.
No, sir. It's clearly visible, right? Slide.
Ma'am, it is still blinking. Minimize this screen.
No?
Okay, now it is good.
Yeah, fine.
Just go like this, ma'am.
Yeah, okay, fine. Basically, the introduction. What is a structure? Yeah, we all know a structure which is based on its deformation and type of primary load. What are the basic primary loads? Which is nothing but axial, flexure, shear, and torsion. While discussing with axial, two types of axial forces are there. One is tensile and another one is compression. Then, while moving to the next stage, different type of combination of variety or various loads. Based on that, we can able to determine the deformation or failure mode. What the structure actually does? It mainly carries the load, which means nothing but the dead load, live load, and some seismic or wind or wave loads. Then, based on the principle of superposition, the structure is either in static or dynamic equilibrium. It mainly transfers the load continuously from the structural components in order to provide load safety, and it transfers the load to the foundation. Then how to access the safe performance of a structure is very simple, whether it is safe or unsafe. We mostly discuss about the case unsafe. Why? Because unsafe is the failure category in which either collapse or failure will takes place in unserviceable condition. There are many there are in structural designs, there are many load factors which mainly governs the safety to the structure. Then I mostly in my structural analysis, I used to compare our entire structure with our body. Take an example that our skeleton is a structural member. Yes, our skeleton is a structural member. Compare with some beam or column. It always used to maintain the shape of the body, and it's also keep our various organs or some muscles in right place. And see, it's compared with beam or column, some structural element, then it will maintain the load, equally transmit the load. Then our structural member transmit the load to the foundation, our body transmit our entire load to the ground. Then example for our tension is nothing but a spider web is a very good example. You till now we can't able to notice how a spider will construct their web. Now from today you people all notice how a spider is constructing its web. It's a very good example for the it's a very good example for our tension structure. Then see here this one is a very good example for our compression structure. Yeah, elephant is standing. Yeah, in one side, one column is there. Other side, some persons are there. One, the compression load is given. The people will fail. This people will fail, and the column will buckle, and it also fail. Next, see, this is an example for deflection and bending. In this tree, one apple is there. At that time also in figure 4, the tree's side, this clamp is bending, but we can't able to notice that. In other figure, see one monkey is there. So in the type, see how the branch of the tree is bending. This is a very good example for a deflection, because we people used to study only in books about structural things, how it will deflect, how it will bend, how it failure. But we always want to study our structural part while comparing with our natural component. When we are comparing with our natural component, we can easy to know how the members will fail and what are the scenarios going inside that, how it will deflect, how it will bend. Next, this is a while seeing our previous slide, we have an idea how the structure actually behaves. Now, in this slide 7, this is a figure building in which there are many type of load. Dead load, which is nothing but the entire building. Then snow load, water tank, wind, peoples, furnitures, car, etc. All this load will be transferred directly to the foundation. If the foundation is stable, then the load transmission is appropriate. For structural part, we want to design only based on this component. Our structural component, dead load, live load, and other some third grade loads. Basically, what is a mechanism? Our structural analysis mainly based upon our mechanism. What is mechanism? It's nothing but a behavior of physical bodies when subjected to some force or displacement, and its subsequent effect of the body on their environment. There are two types of mechanics. One is static, which is in a uniform velocity, and one other one is dynamic, which is in accelerated. Our structural analysis based on mechanics, structural mechanics, it's nothing but the behavior of the entire structure in various kind of loads, and strength of materials in which the deformation of bodies under force. Then, while having a deep knowledge in structural mechanics and structural materials, we can easily move to structural analysis. Structural analysis, it's a main basic for all structural engineers, which mainly used to determine the response of a entire structure on a specified load and the action based on the loads. What are the response of the loads? Two types. One is collapse, which is nothing but your failure. Magnitude of the force, which mainly develops the failure, is called collapse. And another one is serviceability. The entire structure in its service age, how it deforms, its magnitude, its modes, are the response of the structural analysis. Engineer project. We civil engineer. Next, our career moves into a structural engineer. When you take your PG or some other course in structural based on things. Four main points. One is planning phase. Planning phase is nothing but you want to collect the materials, how it behaves, their physical property, all these things. Their structural form, in which structural component, how you are organizing your materials. Second one. And third important point in planning phase is your load. Based on your loads, your structural component size or material will vary. Agreed. Then next stage is your analysis. You have planned all these things. You have collected all these materials, and you have made a reinforcement detail. All these things you want to analyze whether in which case all the bending moment, shear force or torsion, all other component is going on. Then based on analysis, nowadays many softwares are there for structural analysis. Say for example, very basic thing, StatPro. In StatPro, you can analyze any type of structure, water tank, chimney, frames, loading frames, or moment resisting frames. All type of frames you can easily analyze in your software. Then third important point is design. Based on the analysis, based on the value of bending moment, shear, all these things, you want to design. Whether you were previously assigned reinforcement or loads are correct, or if you want to change in an appropriate manner. Then final stages, you are now ready for your construction. The design of a structure, which mainly involves with, as I am a structural engineer, I used to follow 4 objectives in my field. That is nothing but SEUB. S, which represents our safety. The structure. Why safety? How safe the structure is when it is subjected to some various of loads. The next one is economic. I am an engineer. I am very responsible to my society to govern a economical, safety structure without any kind of collapse to my society. Next one is economy, which is nothing but, as we engineers want to provide an economical structure by providing a reducing the cost in materials and overall cost, but we want to provide in an economical way, but we should never compensate our quality of the structure. Then third point is our utility. Utility is nothing but the performance which the structure required is called the utility. Then beauty. Beauty is nothing but the aesthetic of structure. As we engineers, we are very concerned in our structural forms. We should provide a safety of the structure is our primary motto. But even though we also are an engineer, want to provide some aesthetical appearance of our structure. Then why we want to analyze this much things? We want to construct, we will put some beams, either singly reinforced, doubly reinforced. We want to place one column, one slab. That's it. Our job is over. No, not like that. We want to determine all the reactions, internal forces, deformation at any point in our structure, because based on that only we can able to assess that applied loads and forces are insafable measures. Okay, then moving to structural forms. What are the structural forms? There are 3 types of structures, as I already discussed: tension, compression structures, then flexural beams and framed structure. Flexural beam is nothing but framed structure, in which the main design criteria is only based on bending. The next one is surface structure. It's nothing but load carrying by the member action. Either it may be tension, compression, or bending, or shear, or torsion. See, here I gave a wonderful example. This is the tension. As we have discussed in our structural materials, structural analysis in our previous semester, we are very well known about tension and compression. See, take 1 kilonewton load downwards. Then you can feel how the string will subjected to tensile force. In that, place some small cubes, not in concrete. For 1 kilonewton, no, concrete it will never compress. Take some pots of your soil bricks. Take for example, then provide 1 kilonewton load. Then you can feel how the compression is going on inside these clay bricks. This is a tensile failure. You are pulling that in both ends, the tensile force is acting. So how the failure mode will be? It will break. The good example of the tension failure is nothing but your mild steel, which is subjected, which is in your loading frame. One neck will form and it will break. It will break into two parts. But moving to compression failure, if the span is long, based on the centerness ratio, if the length is high, it will buckle and it will fail. If the length is small, it will crush and it will fail. The important things in your structural properties are only two things. One is your strength. What is strength? The strength is, just compare with yourself. Your strength is nothing but amount of stress you are getting. You are in stable condition, then you are a strength. If the stress will lead to your failure, if you are crying, then that time you literally failed. Yes, you can't able to take that stress, so you are getting failed. In the same way, you compare with that building. If the stress acting in the building, the internal stress, it can be able to take, then the structural is in good mode. If it start to deflect and it start to fail, the entire structural member surely it will collapse. Then moving to stiffness. Stiffness is nothing but it's a property of a deformation. Stiffness mainly play a vital role in its failure mode. Why? Because stiffer element deform less. I will show an example in other slide. See it. This is one oval shape, this is one rectangle shape, and this is one triangle. See here, in this oval, is this stiff? Yes, it's stiff. Absolutely it is stiff. But here see, it is deforming at some point. So it is stiff. Next, when applying to a load, then next one, stiffer. Stiffer, which means here it's a rectangle. You are applying load, but see how it deforms. It's stiffer. While moving through a third case, it is stiffest. It's nothing but, yes, see, the material is reduced. Only 3 sides. Here 4 sides. Here how much you want to spend? Yeah, right. Here you are applying load. Any deformation is there? No. So you are satisfied now all these 4 points. Safety, yes, it is stiffer. Then E, economy, yes. Utility, yes, it will carry load. And C, beauty, yeah, it's in aesthetic performance. Next one. What is collapse? Collapse, which is nothing but when load is applied in certain environmental condition, your member is getting failed. Is nothing but your collapse. There are different type of mode of failures. What are they? You already discussed in our structural analysis. Plastic analysis, which gives the plastic deformation, ductile or yielding, brittle failure, buckling in your compression member in column. Buckling may be elastic or inelastic. Then your fatigue, repeated application of your loads. Then vibrations, some resonance. Then finally, the load is transferred to the foundation. If the settlement of foundation or failure takes place, it's also a mode of failure. Then next stage of collapse is unserviceability. If your structure start getting failure, then it is literally unserviceable. Excessive deformation will take place. Acoustic deformation also take place. Here in our structures, mostly we will go for deformation in our structural members other than our acoustic deformation. Then some unexpected load scenarios or unwise design. Yes, we people are very common. We are man. We are humans. We can have some unwise design, but we are not an human, ordinary human. We are civil engineers. We are responsible for each and every structure. So this unwise design should not be recommendable at any situation. Unexpected load, yes, it's not in our hand. It's up to the natural, based upon the natural environment, based on some seismic or some wind, it will collapse. But we want to provide our maximum safety conditions by giving some load factors to reduce this unexpected load scenario also. Next one, determinacy and indeterminacy. Why we want to determine determinacy, determinate structure or indeterminate structure? Basically, I want to discuss one thing. Do you think that every structure, what we are facing practically is an determinate structure? No, no, not at all. Because determinant structure will never govern safety measures. All practical structures, all indeterminate structure. But while designing, we want to convert that indeterminate structure into determinate structure, and we want to put our analysis part, design part, and execute that indeterminate structure as designed as determinate structure by our design. Then we want to execute that structural member. Yeah, we are all well known about the static equilibrium equation, which is nothing but summation of forces is equal to 0 and summation of moment is equal to 0. Here, we can easily see that yes, summation of forces is nothing but force in horizontal direction, Fx, Fy, vertical direction, and F is in third dimension. Moment, when it's in horizontal direction, the moment will be perpendicular direction to that force. Then, say for example, if it is in Fx, then your moment will be in Fz. Similar way, when the moment will act the force, and if you get a perpendicular distance, you can able to get your moment. So the moment always will act in your perpendicular direction. As I discussed, this is a detail about determinate or indeterminate structure. Then it's very necessary to discuss the cables in our structural analysis, because cable are very simple and very useful structure, mainly in our suspension bridge or any roof structure, mostly in our transmission lines. All our lines, say electrical lines, our television lines, all are cable lines. They are mainly in that what kind of force will act, the tension force will act, it will mainly take tension, it never take compression. That's why we are providing sag sag in our all cable members. Then arch, this is a wonderful example for a arch. Two types of arch we will discuss in our structural analysis. One is 2-inch arch, which is an indeterminate structure. Another one is 3-inch arch, which is a determinate structure. See, arch will only take compression force, because based on the compression force, it will transfer all the compression force to the ground and it will be stable. See, this is an example for an arch. Next, we'll go for truss. Why? What is the useful of truss? Yes, because trusses plays a very important role in all industrial buildings. Without truss, our industrial building is none. It's literally zero. Truss. Yes, exactly. There are also two types. One is indeterminate, another one is determinate. See here, is this determinate? Yes, it is determinate. Based on our design, we have converted for our easy calculation, we have converted into indeterminate. But practical case structures of truss are always indeterminate. Why indeterminate? Because we are providing some stiffness or other diagonal members in order to transfer the load equally. See here. In this truss, we can easily give one square. No, we are providing one diagonal member connected with some hinges. Because see, load is transferred here. Upper member and left and right side are subjected to compression force. Down, lower member and the diagonal member is subjected to the tension. Equal distribution of the member forces which lead safety to our truss. Here, this is an example for bending. We are providing 1 kilonewton load. The beam is actually bending, but we can't able to recognize that the beam is bending. But deflection is taking place and bending also taking place. When the load moves higher, we can able to know the literal deflection of the beam. In frame, this is an example for the bending of a beam, horizontal member. This is an example of a frame. See, this bridge deck is a frame. If the load is acting, the bridge deck slab, this governs the load, it's acting. How it will deforms like this in this manner. The both vertical member will deflects outside and the horizontal member will deflects down, then the failure will take place. This is an example of flat plate. Why you are using flat plate? Yes, based upon your structural members, either column or beam, in order to provide the lower head room, we are going for flat plate. This one is folded plate. Here also you want to calculate the forces in this folded edges. Here load is acting and the load is distributed equally through these folded edges. So these are in our fourth point. Here the same load is acting, same distribution is taking place, but here we concern about the structural performance also with our aesthetic view. This one is shells. Shells is nothing but arch which have 3 or 2 hinged arch. Here shell is nothing but our flat plate is given with some deflection here. Why we are giving this kind of shell structures? Because in the structure where the load which transmits the compression force, there if we give flat plates, it will fail. So in order to compensate the compression force, we are providing shells. Idealized structure. What is idealization? Idealization is nothing but this is an structural structure. We want to idealize it. How? Through structural analysis. This structure is idealized in the form of frame with number of bays. Why we want to idealize? Because we want to determine whether it is structurally stable or unstable based on the different type of condition in which our support condition will play a major role. What are the support condition? One is pin connection, next one is roller support, third one is fixed support. Here I will give an example, real time practical example. Pin support, you are well known about, it's an hinge. Okay, take 3 different scenarios. You take, you now at present you are in your room, take your door under lock. Yes, it is in fixed condition because you have locked your door. Is any horizontal movement in your door? No. Is any vertical movement in your door? No. Is any moment? If you open your door and turn, then only if you can able to enter the door or exit the room. It is an example for your fixed support. Take roller support. I will go in this reverse order because then only you can able to understand what I am saying. Roller. roller is nothing but, take one sliding window. You are sliding your window. If the roller is in horizontal direction, you can able to move your window only in horizontal direction, like this or this. This is a perfect example for your lower support. Then your first one, pin connection. Pin connection is nothing but your ordinary window. See, window, it's supported with a pin connection. You are opening your window, closing your window. There, moment is acting and vertical deflection is acting. So a pin connection, there will be a slight rotation with vertical force roller. In which direction you are giving your roller, that direction your rotation or translation will take place. Then a third one is your fixed support, which never allow any kind of rotation or translation. See, this is an example which I gave you. Next, same. See here, this is a beam, a slotted hole, and you are connecting with an anchor bolt. This one is example for your roller. See, one hole and you are connected with some anchor bolt. It's an example for roller. Here see, pin. This is a pin connection. Here only rotation will take place. Forces in vertical direction will take place. So it's pin. Then third one is one pole, fixed. So any moment or any deflection will take place in any direction. No, any translation. A beam have a variety of supports. What types of support? As I told, this one is roller. It's nothing but in which direction you are giving, only in that direction the force will act. Next one is your pin support, either vertical or horizontal. If it is a horizontal member, we can neglect horizontal force. Why? Because same line of force, the forces will act, horizontal force will act, so it absolutely becomes zero. So we will take RS and RY. This is a fixed support. Now you are taking RX, RY, and also one moment. Roller, single degree of freedom, pinned 2 degree of freedom, fixed 3 degree of freedom. Degree of freedom, which is nothing but DOF. We well known about the definition of degree of freedom. Yes, I agreed. But in practical case, how a degree of freedom we can able to understand. Degree of freedom is nothing but very common. The member converted it into one line and two nodes. One member, horizontal member beam will have one line, horizontal line, and will have two nodes. If based upon the supports, the node displacement or rotation is considered as DOF, degree of freedom. Roller will have 1 degree of freedom. How? Roller, which will be small node, what how it will deflect or rotate? It will have only one direction of force perpendicular to it. Yes, it's RY, 1 degree of freedom. 2 degree of freedom means for pinned RX and RY, 2 degree of freedom. For fixed, 3 degree of freedom. What are the displacement rotation is going to be restrained? RX, RY, and its moment. Yeah, here plays a very important role for idealization. Now we are having one small doubt. We want to idealize a structure because sure we want to idealize a structure, real structure, in order to perform modeling. See, this is one actual structure. Here one hook is here. Some load is hanging. Take here which kind of support? It's a fixed support. Here it is one pinned. This one is rigid support. We used to study the moment resisting frame. No, this one. This is a rigid support. Here fixed support, EA is converted into fixed support. Here B, one is rigid thing. And at point C, one force is acting. This is the main performance of your idealization of your structure. So you can able to convert this actual structure in the form of idealized structure in order to perform modeling and to perform the analysis of your structure. Beam, yes, absolutely, it is classified into two things, determinate and indeterminate. See, what are the examples for indeterminate beam? Yes, I actually used to follow with indeterminate first in practical approach, because as I told, all our practical structures will be in indeterminate state. First one is a continuous beam, you know, more than 3 support, it's a continuous beam. Then one is one end is fixed and other end is supported with a pin. The next, then fixed beam. Variety of loads. There are many types of loads: point load, distributed loads, and upright moments. See, these are the examples. Point load, either it may be single concentrated point load or 2-point load, 3-point load. Then distributed load, whether it may be uniformly distributed or non-uniformly distributed. Then is applied moments. Moment will be like C1 or C2, either types. Yes, next, the beam is classified into statically determinate. What are statically determinate beams? The beam which is by the static equilibrium equation is called the statically determinate beam. One is simply supported beam, next overhanging beam, and cantilever beam. Here comes the idealization of the structure. See, in figure A, this pin support. See, this one is a small pin. How it is idealized like this. This one is pin joint in terms of reinforcement. This is one is fixed. See here, fixed. This one is fixed or rigid. Then this one is pin support. I told no example of our window. This one. This can be idealized like this. And this one is our fixed support. It may be idealized either this or this. And this one is your torsion, moment resisting support. Okay, here the stiffness plays a very vital role. Then in idealized structure, all connection and supports are modeled with an assumption. Yes, we have studied all many kind of assumptions. The beam before bending should remain in plane structure, so it should remain plain. The material is isotropic, all these things, elastic and all these things. This one, this is an actual beam. This is an actual beam. Yes. Here, see, there, see here, it's associated with the pre-stressed concrete girders with pads. See how the support is converted. High-shaped one roller, and here it is fixed. See, next one, this is a pin supporter. This is an idealization of that beam. Here, see, it's also a pin support. Here they have using this plate and bolts with nuts. This is an angle. Why we are giving that angle? In order to compensate the deflection. They are giving some angle to make the structure stable. This is a very good example. I told cable structure are a very good intention. Yes, here pin support is there. The cable is, why we are giving one sag in that cable, because in order to maintain the tension force to make the cable stable, we are providing one sag. For that, some angle theta we are giving that, and with using pin support we have connected. Next one is your roller. Here this one is one type of roller. This one is an roller. You can see how the roller is categorized. Only one force is there. Next one is your smooth contacting force. It's nothing but it's similar kind of your fixed support, but here it will not resist the force perpendicular to its line of action of the structure. Next one is your smooth pin connected collar. These are mainly used in your truss member, either in truss or truss bridges. This one is smooth or hinge. Here it is connected smooth. It's a fix, but it will provide two forces similar to our hinge. This is a slider. A slider means which provides this the force perpendicular to it and also the moment, because it's rotating. No, it will govern moment. Then absolutely your fixed support. It will provide force Fx, Fy, and your moment. It will resist all three forces. Idealization of the structure, as I told, this A point which is fixed one, here fixed, and B is rigid, providing rigid. Yeah. Next, moving to the principle of superposition. Principle of superposition is nothing but, see, one load is acting, one deflection Yx is, we are getting one deflection Yx. How we can able to idealize this load and this deflection? By one point load, their Y1 deflection plus the next UVL and its deflection Y2. Then finally we will get Yx, deflection of the entire structure, by idealizing the point load and UVL and adding the deflection of Y1x and Y2x, we can able to get Yx. The what in previous slide, what I told, the same thing I written as a definition. The structure subjected to several loadings, we are dividing that different loadings in single loading and adding all that loading in one side and adding all the displacement in other side and equating both is called principle of superposition. Here it's a linear relationship between your loads, stresses, and your displacement. All these things, material homogeneous, isotropic, linearly elastic manner, it must obey your Hooke's law. If it does not obey your Hooke's law, then principle of superposition will never work out. Then geometry of the structure must not undergo significant change because it's a small displacement only. Then coming to your equation of static equilibrium and condition. Here I told it mainly plays a very important role in your statically determinate and indeterminate structure. Summation of F is equal to 0, summation of M is equal to 0. All these three. 3D equilibrium means Fx, Fy, Fz. For Fx, Mz will play a vital role. For Fy, Mx will play a vital role. For Fz, My will play a vital role. Why? Because moment will act perpendicular direction to your force. For 2D, as I told, Fx, Fy, M naught is nothing but Mz. For 2D, Mz is not there. Third dimension will not be there. So I here mentioned as M naught. This is an equilibrium and determinacy. See here, this is one 2D structure, right? Here you are giving one load P in some angle, it is there, and one uniformly distributed load. Here one roller is there and one pin is there. F1, F2 will be there absolutely, and for roller F3 will be there. Here these three equation will solve. Three equation, three unknown reaction, so it is determined. Then next, see, F1, F2 moment, fixed support, three equation, three reaction force, unknown reaction, so it is determined. Yes, see how it is going on. Here, is it stable structure? Yes. Three equation, three unknown. But it is not properly supported. It's another criteria. You want to deal with this in your analysis part. Here, three equation, but here four reactions. So it is indeterminate. It is statically indeterminate. Difference is 4 minus 3 is 1. So it is statically indeterminate to 1 degree. Equilibrium equation. You all know equation which satisfy the structure which satisfy the static equilibrium equation. It is known as statically determinate. If it is not, it is statically indeterminate. How you can easily able to manage all this thing by drawing a FBD, which is nothing but a free body diagram. Then comes to your stability and determinacy of your structure. What is stability of a structure? It's nothing but equilibrium of structure should be maintained in all cases of load, which means the structure is stable without any failure mode. There are two types. One is partial constraint and impartial constraints. Partial constraint means summation of fx, which never satisfy, because I am giving this determinacy and stability, all these type of members will come there for your exams. So if you can able to recognize whether it is partially constrained or improper constraint, then you can able to know. You can't waste your time in your calculation in fx. So you can easily say for partial constraint, the summation of fx
All the viewers, please wait. There is a technical error. Okay, just wait.
Sir, is this audible to you? Hello? Hello?
Yes, ma'am, you are audible.
Ah, yeah, fine, sir. Sir, I don't know where some technical fault happened. Here now you can able to see me.
Yes, ma'am, you can resume.
Yeah, fine. Two types of structures is there. Sir, where I left for you, all this you saw?
Ma'am, 10 minutes remaining. Sorry,
Ah,
5
yeah.
minutes remaining.
Yeah, fine. Yeah, this is statically determinate and indeterminate. Wait a minute. While going to the statically determinate and indeterminate, there are two main equation. R is equal to 3n and R is equal or greater than 3n. 3n, which mainly represents the number of unknown forces, and R is nothing but the unknown forces, and n is your number of components. If it's satisfied, then you can able to categorize whether it is statically determinate or indeterminate. See, this is an example for your statically determinate or indeterminate structure. Here, many kind of beams are there. One is a simply supported beam, overhanging beam, and different kind of structures is also there. Wait. Then I will move with our trusses. Trusses in detail. What is truss? What are the importance of a truss in a building? Mainly, trusses are used in all industrial-based building. In why industrial, especially for industrial-based building, because trusses will be used in very large span in very vast area to cover vast area. The truss bridge, for long span truss bridge is used. For vast area, trusses in a building is used. There are many type of trusses. Say for example, plant truss, wing truss, warren truss, bouting string truss, 3-inch truss. All this type of trusses can be used. Here there are many type of trusses based on some forces. Say for example, coplanar trusses. Coplanar trusses is nothing but the forces which act mainly in the same plane. And some complex trusses. Why these complex trusses are used? Because in order to provide the stability of the structure, see, we are giving stiffening elements. Here the stiffen element is given, so the trusses in stability in extreme load conditions when we are including some load factors. The next one is stability of these structures. Determining of these structures can be determined by using B plus R is equal to 2J, which is statically determinate, and if it is greater than 2J, it is statically indeterminate. Yeah, whether you have learned it's an M, but here I took as B. Why? Because here I have mentioned B as number of bars. So I took, for easy understanding, I took as B as number of bars. Then next is your stability of the truss. Then next one is your trusses, whether it is determinate or indeterminate. Based on that condition, this three equation, B plus R equal to 2J, which is statically determinate, and if it is greater than 2J, it is statically indeterminate, and less than 2J, it is unstable. Then next one, zero member force. This is a main important criteria for all competitive exams. How you can find the zero member force? If a joint is having two collinear member forces, two force members. What is collinear? The force. What is collinear actually? The forces acting in a same line of action. If the forces not acting in a same line of action, then it is non-collinear. See here, this one is non-collinear, A, point A, and this one is C, it is non-collinear. So FCD is equal to 0. While C, you can make 0 is equal to 0, and FA and FAB and FAE is equal to 0. Then next, second point in collinear is, if the joint is in some three members has been joined, it's the three members of a truss, two members are collinear, and there is no external load. See here, this two members are collinear. So FDC and FDE is equal to 0. Then your last point, this one, see here. Here in this one, in this frame, here this one FCD and FD is equal to 0, and here see, based upon the first point and second point, non-collinear force without loading 0, collinear force with no external loading 0. See here, AG 0 and HB 0, FE 0, CD 0 and ED also 0. So by keeping the points statically determinate, indeterminate, in mainly discussing in trusses or any kind of frames, mainly in competitive exams, we can able to identify first point, the support reactions, what are the degree of freedom, whether it is statically determinate or indeterminate, by using that static equilibrium conditions. Next one, you want to find the zero member forces. If you found zero member forces, then it is very easy. See, all these are zero. If they are asking, please do from the above example, please do find the member force in CD. Then you can, by seeing, you can easily say if CD is an collinear member, BC and CD is a collinear member, absolutely CD is equal to 0. But you can ask why BC is not equal to 0, because here load is acting and it is having not only having CD, here it is also one diagonal member CF, so it will not be collinear. This point, no load acting, so it will be collinear. Based on that, you can identify. I will give one simple 4 steps how you want to identify in your exam. First, support condition. Next, your static equilibrium equation should satisfy whether determinate or indeterminate. If it is determinate, proceed to find the member forces, solve it. If it is not, first find the zero member force, then go for statically determined, change that member forces, and you can able to find the particular force in some particular member. Hope, I think this is an useful webinar to you all people, because I discuss some exam, competitive exam point of view other than your book. So I am expecting you all for your queries. So thank you so much. Any queries is there?
Thank you, ma'am,
Yeah,
for
welcome.
such a good presentation. Ma'am, queries will be there, but students are seeing the live streaming, so they might
Okay,
not
fine.
be able to contact you directly. They might
Okay.
be able to contact me or Prince sir, so we will surely forward you. And thank you,
Yeah,
ma'am.
sure.
In future, we'll be eagerly waiting for connecting with you again
Thank you
for
so much,
another
ma'am.
webinar of